In this lecture, in Module 4, we will be looking at how we can explain some of the things that we have discussed in previous modules with data and information that we just have on the newer concepts. The first among these is how do we relate the QPT, that is the quick P test, to the PSR or the DPS. The PSR is the P saturation ratio and DPS is the degree of P saturation. Now, the PQT procedure was explained in detail in Module 3, Lecture 5. Basically, what this PQT procedure is a simple procedure for determining background P levels in soils on a field basis. That is, you go out to the field and you can almost immediately tell you the concentration of P in that particular soils. In this spot plate here, what we have done is collected samples from the field at 5 centimeter intervals. The surface soil is in the top left-hand corner, and the lowest is at the bottom right-hand in the porcelain plate that's shown here. This has been explained in detail again in a previous lecture. Now, if you look at the color that has been developed using the ammonium molybdate blue method, the Murphy-Riley method, you will find that the color fades with depth, and the background occurs somewhere about 55 to 60 centimeter depth. Now, this information we'll look at in more detail in the next slide. Here we look at QPT versus Mehlich 1P and the PSR. The figure to your left represents has Mehlich 1P on the x-axis and depth on the y-axis, and they represent samples from 2 poultry and 2 dairy manure impacted soils. The horizontal lines indicate the depth to background levels, that is, when blue color in the spot plate fades for 4 sites as determined by PQT. Just look at that's what we just explained. Now, if you look at it, the Mehlich 1P and the PQT for background P at the background P level corresponds beautifully for all the 4 sites. All right. So what the PQT relates to these lab tests as well as the degree of P saturation, which is the one on your right. Now, if you look at the one on the right, what does it actually show? DPS is on the x-axis and the depth to background level is on the y-axis. And you will find a couple of misnomers, something that you don't expect, that is both the blue and the green lines. Why don't they exactly show background levels? Now here what you have is DPS, and of course the PSR can be calculated by dividing DPS by 200. Why these are different is because the PSR does not take into account the capacity of the soil to hold additional P. So what would be best here would be to calculate the SPSC instead of the P saturation. And you have seen that in previous examples, the SPSC indicates exactly where the water-soluble P, water-extractable P, and also Mehlich 1P begins to increase. Now, this is the typical example of the value of SPSC compared to that of the P saturation ratio. Now we move on to understanding biochar application effects using SPSC. Now let us look at what happens when biochar is added to a soil with low P retentive capacity. The figures that you see here are identical to the ones that we explained in Lecture 3 of Module 3. What we did notice is in both cases, the hardwood biochar, which is on the top figure, and the poultry litter biochar at the bottom figure, the P release occurs after identical P additions to the soil and the soil biochar mixtures. The soil biochar mixtures were at 1%, 2%, and 5% hardwood biochar additions or poultry litter biochar additions. The SPSC is calculated from P iron aluminum in an oxalate solution, and the SPSC corresponds to 45 milligram P per kilogram. From the figure, you will notice that at the addition of about 4.5 P to the soil or the soil biochar mixtures, the P begins to be released. Now, if the ratio of soil to solution was 1:10, which when converted would arrive at exactly 45 milligrams P per kilogram in SPSC, and that is identical to the SPSC value. In other words, the SPSC will tell you exactly when the soil will begin to release P upon biochar additions, irrespective of the source or the feedstock of the biochar or the soil in which the biochar is added to. Now we will look at biochar additions to a high P retentive soil. Again, this is something that you've seen in a previous lecture. Now, the hardwood and poultry litter biochar, it begins to be released. They are identical, irrespective of the biochar additions, but they begin to be released at a higher concentration of P added. And this higher concentration is directly related to the SPSC of the soil. The SPSC of this soil can be calculated as 152 milligrams P per kilogram, and therefore that should be very close between the 10 and 25 milligrams P per added that has been added to the soil, as you can see from the figures to the left. So more P can be added to this soil with a higher SPSC compared to the previous soil where the SPSC was 45 milligrams P per kilogram, and until the P begins to be released from the soil. So neither the feedstock nor the rate of biochar has an effect at environmentally relevant P concentration. We will now look at how we can use the recently developed technique to explain the Florida P index and how we can suggest modifications to the Florida P index based on, say, the SPSC. Let us now look at what the suggested modifications are to the original transport potential of the P index. The first column, the site characteristics, include the soil erosion, the runoff potential, the leaching potential, and the potential to reach water body. And you will notice you have a rating ranging from 0 to 8 for each of the soil erosion, the runoff potential, and the leaching potential, and from 0 with a high of 4 for the potential to reach water bodies. Again, the sum of all the values would give the sum for the site and the value for the site and transport. And we have noted earlier, if the sum in the table 1 is 0, then the sum would be considered to be 1. The suggested modification here includes the SPSC, or the factor, as we call it, the capacity factor without the correction factor. You will notice, just let us look at the site characteristics, the capacity index. They are given different ratings depending on the absolute value. What you would notice is it is given a rating of 0 when the capacity index is greater than 40, and 1 when it is between 40 and 20, 2 when it is less than 20 and greater than 0, and 4 when it's between 0 and negative 120, and 8 when it is less than negative 120. As you know, when the capacity index is high, the potential for the P to be released is low. And as the negative capacity increases, it becomes more and more dangerous situation and therefore given a higher rating. The capacity index itself, as it is explained at the bottom of the page, it is simply the difference between 0.1 and the PSR of the soil multiplied by iron and aluminum, and the whole thing multiplied by 31 so that we can express in terms of milligrams P per kilogram of soil. So now you understand why the capacity index is thought to be a better modification to the Florida P index, and we are currently working further on using the capacity index. It's not finalized. We are thinking it is the P index is a work in progress, and this is one of the suggested modifications based on new research information. Here we have a couple of related publications. The first relates to the biochar applications, and the second relates to the QPT, the quick P test.